Good afternoon, this is Mr. Precella, and today we're going to begin the first section that uses the graphing tools that are embedded in the Pearson MyLab course. And to get us started, I'll mention what I mean by a rectangular coordinate system. A rectangular coordinate system
is what most people think of as graph paper.
Yeah. The XY grid, an XY grid, I hear people call it that. There's a vertical number line and a horizontal number line. The horizontal number line is frequently called the x-axis. The vertical number line is called the y-axis. The point of intersection of the two number lines corresponds to 0. So right there, that point of intersection is 0. And then on the horizontal number line, it's exactly what you expect with the number line. To the right is positive. To the left is negative.
And I was looking for some graph paper, but I don't have any.
And, well, they're not using graph paper, so I can do it freehand here. Going up, on the vertical number line, up is positive.
And the future physicists might be saying,
and
wait a
down
minute.
Is negative. Yes,
Up
this
should be
isn't
negative,
physics.
but this isn't physics. This is math.
And we traditionally have up positive and down is negative in mathematics. We can refer to any spot on this XY grid using something called an ordered pair. For example, this spot right here, we have that little dot. Your movement always starts at this point of intersection. This point of intersection, that's where 0 occurs, is frequently called the origin, because this is where your movement originates. The first thing you do is you do your horizontal movement. Starting at the origin, you have to go 1 unit to the right to get lined up with that point there. So we'll say the x coordinate is 1. You then have to move 3 units up, 1, 2, 3, to get to the actual point. So that spot right there on the graph can be referred to using the ordered pair 1, 3. Realize that the ordered pair 1, 3 is not the same thing as the ordered pair 3, 1. The order in which you write those numbers matters. That's why it's called an ordered pair. If I wanted the ordered pair 3, 1, I'd go to positive 3 on the x-axis and then only go up 1 unit. So the order in which you write the x and y coordinates does make a difference. What about this point right there? We'd move to the left to line up with that point. So we'd go 3 units to the left. So the x coordinate is negative 3. We then have to go up 1, 2. So the y coordinate is positive 2. And let's see, I'm going to let y'all tell me the coordinates for this point right there. What would the coordinates be for this ordered pair? Okay, so the x coordinate is negative 4, I agree. And the y coordinate is? Negative 2, I agree with that also. We went 4 units to the left and then down 2 units. What about this point? Y'all see that point there? What would it be in terms of ordered pairs? 2, I heard a 2. And negative 5, I agree. Starting at the origin, you have to go 2 units to the right and then 5 units down to actually get to that point. Notice how the two number lines split the plane, a plane is any flat surface, a plane, not a plain.
No. Is it
Yeah.
the way?
No,
Oh, yeah, I am.
plane.
Yes, you're right.
Oh,
You're right.
okay. Into four distinct regions. These four distinct regions are called quadrants, and quadrants are generally labeled using Roman numerals. Starting in the upper right-hand corner, we would say this is quadrant 1. Then we move counterclockwise. This is quadrant 2, quadrant 3, and quadrant 4. We can make some generalization about signs when we look at the points in these quadrants. For this first quadrant, quadrant 1, I think we can convince ourselves to get into quadrant 1, you have to move right and then up. That means your x-coordinate will always be positive and your y-coordinate will also be positive. What about the ordered pairs out here in quadrant 2? Let's get a generalization involving signs. To get into this quadrant, you have to go to the left. That means the x-coordinate is going to be what? Negative. And then the right, you go up, so the y-coordinate is positive. So you expect ordered pairs in quadrant 2 to be negative and then positive. What about quadrant 3? You have to go left and then down. Negative and negative. What about quadrant 4? Right and down. Positive and negative. Okay. And we assume that you've worked with an XY grid before and that this isn't something that's totally new to you in for this material.
And if it is totally new to you, that just means you got to work harder than someone that remembers this graphing stuff. Okay? So
It doesn't mean you can't do it. Just make yourself work harder. Let's identify some points on the axes themselves. I'm looking at this spot right there. It's at the number 2 on the x-axis. Let's see if we can figure out the coordinates for this point right here. We start at the origin, and we have to go 2 units to the right, so that means the x-coordinate is 2. What's the y-coordinate? 0. You don't want to go up or down. Let's see if we can notice a pattern about all the points on the x-axis. What about this ordered pair right here? What would that be? Negative 5 is the x-coordinate. What about the y-coordinate? 0. For points that are on the x-axis are called x-intercepts. An x-intercept, I-N-T-E-R-C-E-P-T, an x-intercept is a point on the x-axis. And we can make a generalization about the points on the x-axis. If a point is on the x-axis, you'll move left to right, but you're not going to go up or down, so that means every y-coordinate has to be 0. So for an x-intercept, by that I mean a point on the x-axis, every y-coordinate is equal to 0. So the ordered pair will be x, 0. And that is important. Every point on the x-axis has a y value of 0. Let's apply that same logic to points on the y-axis. Points on the y-axis. That point right there. Well, I'm starting at the origin. Can y'all see it? It's up there at 5. Okay? We're starting at the origin. How many units left to right are we going to move? None. And so for that ordered pair there, the x value is 0. You don't want to move left or right. You want to stay right there on the y-axis. And then you move, what's the y-coordinate? 5. What about this point right there? How would you express that using an ordered pair? How many units left, right will we go? 0. And then we go down 4 units. Every point on the x-axis must have a y value equal to 0. What about points on the y-axis? What can we conclude? To be on the y-axis, can you go left or right? No. So what can we conclude about the points on the y-axis? That their x values always have to be 0. Y'all don't seem too confident about that. And with a little thought, it should be obvious. If it's on the y-axis, if you move any way, left or right, are you going to be on the y-axis? No. So any point on the y-axis must have an x value of 0. And then the y value is whatever number's there on the number line. I better write this out. I'm going to say a y-intercept. Y-intercept. That's a point on the y-axis. And every point on the y-axis, instead of having a y value equal to 0, every x value will be 0, so you expect the ordered pairs to be of the form 0, y. And now we're going to graph lines, parabolas, conics,
Cubics?
cubics.
Absolute value.
Absolute value.
Square root.
Square root. Is there anything else? No, I guess that's it. We're going to graph 5 general shapes today. And any questions before we go on?
Oh, wait. I was going to move to problem 1, but I guess you want to write a little bit about lines.
Yeah. First thing we're going to graph, we said there'd be 5 general shapes for graphing. The first one, lines. Lines have equations that have x's and y's. They don't have x squares. They don't have square roots of x. They don't have y cubes. All they can have is an x and a y. At least one of those. So the equation will be in the form ax plus by is equal to c. X and y are the variables. A, b, and c are constants. And at least a or b can't be 0. If a and b were both 0, you just have 0 plus 0 equals 0. That's not a line, that's nothing. Because 0 equals 0. So realize you've got to have at least an x or a y. If you're going to draw a line, how many distinct ordered pairs do you need to draw a line? What's the fewest number of ordered pairs you can have? 2. Okay, what we're going to do is we're going to find 2 ordered pairs that satisfy the equation of a line, and then we'll connect them. That's how we're going to graph lines today.
Except you're going to be using...
But we're going to be using a graphing tool. Yes, but the theory behind it, we're going to find 2 ordered pairs and then connect them with a line. So let's look at number 1.
Okay. Hey, at this point, you don't have to click on all of these to see the problems, but you still got to, or else you're going to miss 16.67% of the problem. You're not going to make 100. You're going to make 80. What? 3 points.
We're assuming at this point that we need to click those media assignments, even if you don't have to watch them. And you're here right now, so hopefully you'll understand everything and won't need to watch those videos. But even if you don't need to, you still got to click them if you want to get the points. So this is number 1. Here's the equation they want us to graph. 3y equals 5x minus 15. It says, give ordered pairs that are solutions and graph the equation. They're giving us a table of values. Complete the ordered pairs so that they are solutions to the given equation. Look at this. I'm going to make the little table. X and Y. There. They have a blue box right here. And that table, what it's saying there, there's a meaning to that table. Who knows what they're saying? They're saying for the x variable, go to the equation and do what? Okay, make the x be 0. So the first thing to figure out that number there, we're going to plug in 0 for x. So we have here, x equals 0. That gives me a 3y equals... Oh, wait. Thanks. Okay. So we're plugging in 0. So we have 3y equals 5 times 0. What's 5 times 0? We can do that in our head. 0. So you have 0 minus 15. What's 0 minus 15? Negative 15. We know what to do to get rid of that 3. We want y by itself. So what are we going to do? Divide by 3. Just seeing if y'all are awake or if y'all have dozed off. Negative 15 divided by 3 gives me a negative 5. So I've just found one ordered pair. The ordered pair is 0, negative 5. Hey, we know, I can picture where that point's going to be. Left, right, 0, down 5. Where would that be on an XY grid? We're going left, right, 0, down 5. If the x value is 0, then you expect the point to be on the y-axis.
So you're saying you just found the y-intercept?
I just found the y-intercept. I just now found the y-intercept.
I'm
going to label that.
Oh, wait.
There.
I'm plugging in.
We're not plugging
Negative 5. Check it.
Now, y'all said we need 2 points. We can't draw a line just using one ordered pair. So we're going to have to find another ordered pair.
Okay.
Look at this second row. Look at that second row of the table.
What is it saying to do here?
We have a 0 there. And I'm a blue box.
You're in the Harvard Center and someone's doing this and they say, hey, what am I supposed to do here? What would you say? I'll help you out. Plug blank in for blank.
Yes. So for this next one, now it's saying plug 0 in for y and find the value of x. So we're plugging in 0 for y. Y'all like the way I'm writing so small? Y'all are thinking to yourselves, this isn't Timothy Precella. That's Anthony Precella writing so small. Yeah, I'm trying to write a little neater today. So plugging in 0 for y, 3 times 0. What does that say? I remember years ago when we were doing this in Math 371, and I had a student, a good student, and I didn't understand why she was having so much trouble. She was coming up with the weirdest numbers for this.
9. That's what she would have said for this problem. Right?
She was doing exactly what I said. Plug in a 0 there, and so that became 30 equals 5 times x minus 15. She moved the 15 over. She was very consistent. This is before MyLab, before when we used books and stuff. And I had to look at her paper and find. Did you walk into the office and look at it?
I walked in and looked and said, no.
multiply.
I had a student that did that.
Oh, okay. I hadn't run into
Yeah.
that. Okay, but that was decades ago. Wow. Yeah. Okay. Well, anyway, 3 times 0 becomes 0.
It's not 30.
Equals 5x minus 15. I'm just going slow today. I enjoy this, so I'm going to take
keep
my
them
time.
here as long as possible.
No, okay. Y'all tell me what to do. Okay. What will I do next? Move the 15 over to give me 15 equals 5x, and then divide by 5. Someone's figured out.
The way you said move the 15 over, you're thinking like us.
Okay.
Get as few negatives as possible, okay? Rather than moving the 5x over.
15 divided by 5 is 3. So here's my second point. So,
3. Check it. And now here comes something new. Well,
they want us to use the graphing tool on the right to graph the equation. What I do is I click to enlarge, and that gets the graph all there, and you don't have to be scrolling or anything. But these graphing tools don't just do the graphs for you. You have to know what you're going to be graphing. You know it's going to be a line. So the first instructions, click the graph, choose a tool in the palette, and follow the instructions to create the graph. You need to choose a line tool. Look at that tool he's looking at right there. Use your bionic eye. I think that's a circle tool. We'll be seeing that in 2 assignments, okay? We'll be seeing
this one. What does it say?
Absolute value, that V shape. There's one that looks, show them the pointer. The pointer, move up. The pointer right there. There should never be a time you use that, okay? So don't say, well, that looks like a line. There's no time that you're using it. Look at that one right there. It's hard to tell the way we've blown it up, but it's a picture of a line, and there are 2 blue dots on the line. That's what we're trying to draw a line. And how many ordered pairs did we find? 2. So that's the line tool. You click that.
Okay. And then notice the instructions in the yellow rectangle. Click the graph to plot the first point. What was the first point?
0, -5.
So notice, look in the upper right-hand corner of the yellow rectangle. You see it tells you what the point you're on. So over 0, gosh, it's harder and harder for me to see this as I get older and older.
That's why I keep looking at that box. The box to see that 0, -5.
0, -5. Y'all see where I'm talking about it?
Point it to him right now.
Well, if I do that.
Well, did you click? Click it. So you click it.
But it's still, let's see.
Yeah. There. Oh, there it is. Y'all see the 0, -5? Now as you move your mouse around, it's drawing every possible line that passes through the point 0, -5. So it says we got to plot the second point.
What was that second point?
That was the x-intercept. That was 3, 0. So write 3 up 0.
Am I at 3, 0?
Y'all see where it says 3, 0? It's underneath that X. And some of the grids are going to be extremely tight. They may start counting in units of 2. So it's important. Don't think, oh, I can tell those units counting. It'll get to a point where you're going to need to be looking at the coordinates there under that X to be able to tell where your pointer is.
Okay.
So you click there.
Now you got to move it from here back to over here.
The original.
Save it. And it's hard to see it like that. Hey, let me see. Can I do this?
You can do that.
But anyway, and also check answers.
Let me see something. Any questions there?
We're going to try making it smaller, but that's going to make everything smaller.
You're right. That's not any good. Yeah.
Okay.
Let's do another one. Let's go to number 2.
Is this another line? What do y'all
It just
think?
has x's and y's, no exponents. The variables aren't in fractions. The variables aren't under square roots. I don't see any absolute value. This one here is even in standard form for a line. AX plus BY equals C. So, yes, this is a line. You've got to know that you're trying to graph a line so you know what sort of which button to click on the graphing tool. 3x plus 2y equals 6. Hey, look at that. They didn't give us a table. Go back to what they have there. Look at what they've done. What does that mean? We have a 0,
Plug
comma.
blank in for blank. What's it saying?
So it's saying the same thing. Switch to my paper. It's saying to do the same thing that we did up here. Here they used a table. Now they're representing it in ordered pairs, but it's still the same idea.
First number
The
is always
first
X.
number is always x. So plug in 0 for x and find y. So here we go. We're going to plug in 0 for x. Three times 0, it's not 30. What is it? 0 plus 2y equals 6. That means 2y is equal to 6. And then divide by 2 to give me y equals 3. So I found my first order pair.
Punch it in.
But we need 2 ordered pairs to draw a line, so
I wonder, what do y'all think the next one's going to be? What do you think it's going to say? Could y'all predict it? Huh? 0 for y. Yes.
I bet you that's right.
The basis of all IQ tests involve patterns. If you can spot patterns. And, yeah, that's what they're doing. Plug a 0 for x, then a 0 for y.
So, you know something? I put those little wavy lines to separate the work. Here's the work when I plugged in 0 for x. Now I'm going to plug in 0 for y. That'll give me a 3x plus 2 times 0 is equals 6. So really all we have is 3x equals 6, which means x is equal to...
Yeah, that's right, Tim.
I'm waiting for them to tell me.
But you've already said it.
Well, we divided by...
equal to...
Oh, I meant x is equal to what number? And
Yeah,
y'all
no.
say 2. Okay, there. So we found our 2 ordered pairs. And the way we have to have this stuff blown up here, if you're using your own device, Genesis, is your graph here on the right real big, or it fits in so you don't have to
do you click to enlarge or
do you
not?
click to enlarge or not?
Okay.
Genesis is sitting there working problems in the homework like what we're doing right here, and I admire anyone that can do that, because if I tried to do that and someone else is talking saying 0, 5, I'd be trying to plot 0, 5, not my own
Yeah,
point.
but you have a 60-year-old.
But I have a 60-year-old brain, you're right.
Okay.
Still
Zero,
dealing with the
3.
effects of that cancer treatment also.
Okay, so am I at the right first point? No. I was at 3, 0. What's the first point I'm at?
0, 3.
0, 3. Oops.
Oh.
Oops. Wow, I'm having a... There. Am I at the right point at last?
Click
Yes,
it.
so click it. Now let's see every possible line that goes through that point. Look at that. And now, what's the second point?
2, 0.
If you click the wrong one, I just say cancel and start all over.
Is that it? Nope.
Oh, wait.
There.
Okay, there. I'm at it. So that's the x-intercept. It's on the x-axis, right?
Right.
So,
Save it. Any questions?
well, I have to check it. They want to make sure it's right.
Okay. Tony,
Mm-hmm. Oh, okay.
So Tony's going to go see if he can find a mouse pad for this computer. Make the mouse not be quite so touchy. But the first thing we're graphing, the most basic shape, would be lines. Any questions here? Plot 2 points and connect them using the line tool. The second shape we're going to graph. These things will be quadratics. Well, let's think about when you're solving a quadratic equation. A quadratic equation has a special term in it. It doesn't just have an x and a y. What does it have? What must it have to be classified as quadratic? An x squared. So the equation must have an x squared. We'll do more discussion with quadratics. We have a really good assignment coming up in a few weeks where we look at quadratics in more detail. But for our purposes, instead of ax squared plus bx plus c equaling 0, you have y is equal to ax squared plus bx plus c. And the graph of a quadratic is a smooth U-shaped figure called a parabola, P-A-R-A-B-O-L-A. And a parabola, it's a U-shaped figure for our purposes. They'll either be opening upward or downward. We'll get a more advanced graphing tool for quadratics in a few weeks' time. But for today, we're going to have a 3-point quadratic tool, okay? We're going to have to find 3 ordered pairs that are solutions and then use the 3-point quadratic tool to draw the graph. Let's look at number 3. For the equation y equals x squared minus 6, create a table with at least 3 ordered pairs that are solutions of the equation, and then graph the equation. Well, we're not going to be using at least 3 ordered pairs. Here, they tell us we're using exactly 3 ordered pairs. So let me write down the problem and write down the table. This is number 3. The equation that we're trying to graph is y equals x squared minus 6. And we have a table x, y. We're going to plug in, this is saying plug in -2 for x, then we're going to plug in 0 for x, and then we'll plug in a +2 for x. Notice here we're not plugging in numbers for y. We're generating the ordered pairs just by plugging in for x. And that's being nice. It's easier. If we had to plug in numbers for y, we would have then probably had to use the square root method to try to find the solution for x. So they're actually doing us a favor here by only having us plug in for the x value. Let's start off with x equals, this is saying plug in -2. X equals -2. Oh, thank you. Oh, good. Thanks. There. That's saying, oh my goodness. Had I not switched to this, I was writing all this stuff down. Did y'all see this stuff? Yes, I had. So, okay. Okay, so we're plugging in -2. So we have y equals negative 2 squared. What's negative 2 times negative 2? I think we can do this one in our heads without having to write that stuff out. What did you say negative 2 times negative 2 is? Positive 4 minus 6, which gives us a y value of negative 2. So there's my first order pair, negative 2, negative 2. I put the little squiggly marks so hopefully you can tell. Here's the table. Here's where I plugged in negative 2. Now we're going to plug in 0. Let's plug in 0 for x. That's going to give us a y equals 0 squared is 0 minus 6. I agree with the negative 6. So there's my second ordered pair. Third and final order pair, they want us to plug in positive 2 for x. Plugging in positive 2 for x, we get y equals 2 squared is 4 minus 6. Looks like we're getting another negative 2 for y. Any questions on how we filled in the table? Here they gave us the numbers they wanted us to plug in. And they were all x values. Okay, I'm going to switch over. I got to type in. That's a negative 2. Here was a negative 6. And right here, another negative 2. And check. Okay. And now they want us to draw the graph. I'll click to enlarge this thing. I'll expand the instructions. We have to choose a tool in the palette and follow the instructions. Which one of these looks like it's a parabola? Notice these things are, there should be a smooth U-shaped figure. A U to me, by the way, a U has a smooth turnaround. It's not a sharp point. A sharp point would be a V shape, and there's a different type of equations of V's as their graphs. Parabolas are smooth U shapes. So, which one of these tools? Certainly not the line tool, and this is a V right here, and it says absolute value. Look at this one. 3-point quadratic tool, that's the one we want. Even if your parabola were opening downward, you'd still use the 3-point quadratic tool. So you click it, and then it says, look at the instructions up here. Click the graph to plot the first point on the curve. What was our first point? Negative 2, negative 2? Is that it? Oh, I moved accidentally there. Click it. Now, what's the second point? Next point was 0, negative 6. And now look at, they want me to plot the last point. As I move my cursor around, it's drawing every possible parabola that could contain those 2 points. Okay? The third point was what? Positive 2, negative 2, is that it? Y'all see where it says 2 comma negative 2 underneath that big X? So we click it, save it, it'll transfer the graph back to the original grid, check answer. Any questions there? Okay, number 7. We want to graph of y equals negative 2x squared. There's a big difference between problem number 3 and problem number 7. What's the big difference? They didn't tell us what numbers to plug in. They didn't tell us what numbers to plug in. So it's up to you to decide the numbers you plug in. You can decide, oh, I'm going to plug in 10 for x. If you plugged in 10, 10 squared is 100, times 2 is negative 200 on these little computer grids that they're given. These little computer grids that they're giving. Can you count down 200 units? So whatever you're going to use, my advice to you, use numbers that are close to 0, okay? You could use the numbers they had a moment ago. You could have the negative 2, 0, and positive 2. I think I'll use, let's see, what will I use? Maybe I'll use negative 2, 0, and positive 1, just to change things up. But y'all get to decide which x values you use. But you have to use something that will fit on the grid. If you try to use 100 for your x value, there's no way they're going to have a grid big enough for you to count out 100 units to the right. So let's make our table of values. Why don't we plug in, what do I say, negative 2, 0, and positive 1. So let's start off with that x value equaling negative 2. X equals negative 2. Then y is equal to negative 2 times negative 2 squared. Remember your order of operations. You perform exponentiation before you perform multiplication, division, addition, or subtraction. So the first thing you need to do is this exponentiation. What's negative 2 squared? Negative 2 times negative 2 is positive 4 times negative 2. What are we getting for our y value here? Negative 8. So there's the first order pair I'm going to plot. I think we can do this x equals 0 without writing down anything. Take the 0, plug it in for x. What are you going to get?
Negative 200 and negative 2, 0, 0. I'm joking.
Okay. 0 squared is 0 times negative 2 is 0. So my y value, we're going to have a point at the origin. And the last point, you have to plug in 1. X equals 1. So we have y equals negative 2 times 1 squared. Let's use the order of operations. 1 squared is, so we have negative 2 times 1. What's negative 2 times 1? Negative 2. Any question on my calculations? But you get to choose. If they don't tell you what numbers to plug in, you get to choose the numbers. Technically, I would have used, normally, if I were just doing this for my own education, I would have used negative 1, 0, and positive 1. But here I changed it up a little bit. I thought I'd use negative 2, 0, and positive 1. That's all we're doing. That's it.
Is this it?
Mm-hmm.
Okay,
So we choose our 3-point quadratic tool again.
3-point quadratic.
And then you plot the first point, negative 2, negative 8.
No. Negative 8? I don't see
Negative 2,
okay,
negative
yeah.
8.
Okay, negative 2, negative 8. Nope. I'm at negative 3, negative 8.
Is that it? Negative 2, negative 8? They're beside those double arrows heading down?
Yeah.
There. Now the origin, 0, 0.
Okay, 0, 0.
Okay.
Oops.
Yep.
Oh, what am I doing?
I think this mouse pad is making it even worse. There, click it.
And now,
as we move around, are you sure that's 0, 0 that we have right there? Yeah, okay. Then notice as we move around, it's every parabola that could possibly contain those 2 points. So you need 2 points on a line to uniquely determine a line. But if you're going to plot points by to graph a parabola, you need 3 points to uniquely determine that parabola. And we'll discuss more. What is it? 1, -2. We'll discuss.
I think I was doing.
I think you were. Is that it?
Yeah. 1, -2.
Save it, and there it is. And check. Some terminology. Every parabola is going to have a vertex. If it's opening downward, the vertex will be the high point. And in the previous problem, no, it was on number 3, wasn't it? Number 3, notice the vertex, when it's opening upward, the vertex is the lowest point. Well, to draw a parabola, you've got to know the vertex, okay? So we're going to have a formula as we get further into our analysis of parabolas and quadratics. In a few weeks, we'll get a nice little formula that we can use to determine exactly where the parabola occurs. The vertex occurs. Then, notice these things are mirror images. If you had the vertex and just 1/2, you could just imagine folding the paper over and drawing the mirror image on the other side. They're symmetric. So the right-hand side is the mirror image of the left side.
We'll discuss all of that in a few weeks. You're just trying to
really
give them something to look forward to.
Yes.
Okay, let's do cubics.
Cubics.
So quadratics have a square.
What do y'all think is the exponent for cubics? Well, while I write this down, switch over to my paper.
Which paper?
Oh, oh, you already have me there. Cubics.
Right.
What do you think? Don't tell. I'm gonna let them tell me. Don't say it, Tony. What exponent do you think the equations have to have for them to be classified as a cubic? A 3.
Yeah.
It must contain x squared.
X cubed.
X cubed, my goodness. X cubed. So, there's no nice name for the picture of a cubic. Some people, Tony has this real scientific name that he uses for cubics.
It's called a squiggly.
Okay.
A good student, made up that name years ago, and I said, I'm going to remember that. And she's probably shocked. I'm still remembering that she gave it the name cubic. I'm sure she doesn't remember giving it that name.
The graph of a cubic is a squiggly. So y equals x cubed, is it -6?
And
look, they're giving us the table.
So why don't you write down the whole table and fill in all the points.
Okay. I'm writing the table. So, -1, 0, 1, 2.
I'm going to move over and show that.
Okay. Here, they're not telling, you don't get to choose your x values. They're telling you which ones to plug in. So, here we go. We'll start off, we'll plug in -1 for x. So we have a -1 cubed minus 6. What's -1 times -1 times -1? No, -1 times -1 is +1 times another -1. A -1, okay. Remember, that's why I like odd exponents so much. signs don't change.
Thought you were going in the order.
Oh,
Just
okay.
-1 times
Negative 1 is
That's
positive 1. Times another negative 1 is negative 1. So what are we getting for our y value? Negative 1 minus 6 gives me a y value of negative 7. And now we'll plug in 0 for x.
Might have been able to do that without any writing.
I bet we could have. This is a sharp bunch. Plugging in the 0 for x. 0 cubed is 0 minus 6 gives me a y value of negative 6. There's my second ordered pair. The third ordered pair, we're going to plug in 1 for x. We're going to plug in 1. And let me make a little squiggly. So we can tell. Okay, we're plugging in 1 for x. So we have y equals 1 cubed minus 6. Well, what's 1 cubed? 1 minus 6 gives me a y value of negative 5.
Are y'all caught up with them? Any questions how we're getting these numbers?
The first 3 points look like they could almost be on a line. Okay, notice as we increase x by 1, each y value was increasing by 1. Following that pattern, we get a negative 4 for 2. But I don't think this is going to continue. When we plug in 2 for x, I think we're going to start moving further away from the x-axis. What are we going to get? Well, no, I guess we're not. We're getting closer in this case. So we have a 2 cubed minus 6. What's 2 cubed? 8 minus 6.
2 times 2 is 4. 4 times 2 is 8. So you got the 8 for 2 cubed.
8 minus 6 gives me a y coordinate of 2 for my last ordered pair. The first 3 points look like they're on a line. And when we start plotting this using the graphing tool, you'll see what I mean. Is everyone caught up?
I've got to type in these numbers.
Negative 7, negative 6, negative 5,
negative 5,
and positive 2.
Positive 2. And now we're going to graph. Oh.
Uh-oh, I don't see, let's see, do you see anything that sort of looks like a squiggly there? Which tool sort of looks like a squiggly? What do you think? What about that one right there? Hover over it. What does it say? 4-point cubic tool. Isn't that what we have here? We have 4 ordered pairs, and the graph is going to be of a cubic, that's that x cubed. And look at how they've changed. The horizontal units are big, the vertical units are real narrow. So, but we click the 4-point cubic tool. Y'all see the one he's clicking on? Click it.
And now,
click the first point.
Oh.
Clicking the first point, -1, -7.
-1, -7. Oh, wait. Am I -1, -7? Yeah. Oops. I said yes, and I'm not anymore. Okay.
You know, I think that you're worse off with the, that's -1, -7. Oh, yeah, that's right. That's what we needed. Okay, 0, -6.
0, -6. I'm
1, 1, -5. And look at this. When he plots 1, -5, doesn't the graph, wait, there, doesn't it look like a line? The first 3 points make it look like a line. But now, 2, 2.
2.
2, there.
2. See it?
Mm-hmm. you expect one side of a cubic to be extremely steep going upward. The other one, notice it's real steep going down. There it is. Let's check our answer. Any questions there? So we've done lines, quadratics, cubics, Roman numeral 4. The fourth shape that we're graphing today. Absolute value equations.
You'll spot those because guess what you're going to have?
A cubic has to have an x cube, a quadratic an x squared. An absolute value expression, what do you think must appear in the equation? An absolute value. Absolute value bars have to appear. So when you look at number 5, look there, you can spot it. Y equals, it has the absolute value of x minus 6. Now, I need to write a little bit about an absolute value equation first before we draw the graph, okay? But an absolute value equation, remember I said a quadratic was a smooth U-shaped figure opening up or down. An absolute value isn't U-shaped, it's V-shaped. It has a sharp point. It'll either open upward or it's going to open downward. For all of the shapes that we've graphed so far, the order didn't matter. I could have started off plotting -2, 2, 2, 2, and then plotted -1, -7. You'd still get they just say plot a point, plot the third point. So the order in which you plot the points doesn't matter for lines, quadratics, and cubics. Most people would do what I did, just plot them in the order in which I found them. But for an absolute value graphing tool, the first point you plot must be the vertex. The vertex is the point where the graph changes directions. That's the vertex. With parabolas, we'll do quite a bit of work with the vertex of a parabola when we see that other assignment in a few weeks. But for now, for absolute values, the vertex is that point there where it's changing directions, and you can determine the location of the vertex because the vertex occurs, OCCUR, when the expression inside the absolute value bars is equal to 0.
When the
inside stuff, yeah, that's what Tony likes me to say. When the inside stuff is equal to 0. And you're going to have to plot the vertex first. When you're plotting these V shapes for the absolute value tool, you must plot the vertex first.
And you're saying that, but the instructions, the Pearson will say plot the vertex, okay? And it'll tell you when to do it.
Most people don't read the instructions, so I'm guilty of that same thing on other matters.
I studied the instructions that student's teacher told him to do back in 1991.
Okay, so
go ahead and write down this problem.
Look, before we do anything, when you look at that equation, can you tell me what x value will have the vertex? When does that inside stuff equal 0? When is x minus 6 equal to 0? What would x have to be? No, if x were 0, you'd have 0 minus 6. In order for that inside stuff to equal 0, what would x have to be? 6. that's where the vertex will occur. So when they're telling us the x values to plug in, they're going to have to give us a 6 along the way. Let's see. Let me write the problem down. This is number 5. And we're wanting to graph y equals the absolute value of x minus 6. And they're giving us a table. And what's the first number they want us to plug in?
-3 for x.
So we're plugging in a -3 for x. We're plugging in -3 for x. So we have y equals the absolute value of -3 minus 6. What's -3 minus 6? -9. What's the absolute value of -9? +9. So there's the first order pair we found is -3, 9. It's not the first order pair that we're going to plot though. But we to go and type in -3, it's -3 +9. I think it's a -3 -9. But you go and type in a 9. Look at the next number they want us to plot. What is it? 6. I knew they'd have to give me 6 because that's where the vertex is. Plug in 6 for x. Then you're going to have y equals the absolute value of 6 minus 6. 6 minus 6 is 0. What's the absolute value of 0? 0. So 6, 0, that's going to be where the sharp point is on the graph.
Oops. 0. Oops.
And what's the last number we're going to plug in? Looks like it's 14. We're going to have to plug in 14 for x. Plug in 14 for x. Plugging in 14, that says y is equal to the absolute value of 14 minus 6. What's 14 minus 6? 8. What's the absolute value of 8? No, I think that no. How far is 8 from 0 on the number line? 8 units. The absolute value of 8 is 8. The absolute value of -8 is still +8. The absolute value is not negative. You're asking yourself, how many units from 0 is 8? And if you started counting, it'd be 8 units. Any questions there?
Punch that one in. 8. One year, one semester, I had literally everyone in the class email me about this particular problem.
Well, first of all, you choose the tool. We want the absolute value tool. And there's only one thing that looks like a V. Where is it? Right there. And if you hover in small print, it says absolute value tool. You click that. And now look at the instructions. What does it say to do? Click the graph to plot the vertex. Which point? Look back at my work. Which point was the vertex? The vertex occurs when the inside step is 0. When was x minus 6 equal to 0? When x was 6. There's the vertex. So that's the first point you have to plot. 6, 0.
And maybe now to see why, what we mean by this.
Y'all see what I mean? The
vertex
vertex occurs when the inside step is equal to 0. And in the next, we're going to graph one in a moment, where you're going to have to choose the numbers yourself. And so you're going to have to know what number to plug in to find that vertex. So let's go back. Oh, goodness. Look how tiny those units are.
Oh, gosh. What was the vertex? 6, 0?
Yes.
So that means right 6, up 0. I'm at it.
Click it.
There.
And now look at what happens as you move the mouse around. It's taken into, we found 3 points, but I don't think we're going to need 3 points. I think it's using symmetry. Notice the right-hand side of the graph is going to be the mirror image of the left side. So it says, plot another point. Well, which point do y'all want to use? It makes no difference to me. Do y'all want to use -3, 9 or 14, 8? Doesn't matter to me. We just need one of them. They made us find 3 points, but we only need 2 points for the graphing tool. So, which one? Wrong one. Which one do you want to plot?
Let's do the first one. -3, 9.
-3, 9.
Okay. Oh, what's next? -3.
+9. I think that's it.
That's
Click
it. Now, what was that other point we didn't do? 14, 8. 12, 13. There's 14. And is that up at 8? Well, at this point, it won't show the points.
But you'd still get the same parabola. I mean, V-shaped figure if you had plotted 14, 8 instead of -3, 9. And we're going to check our answer. Any questions there? Let's do number 8.
One day I'm going to go through and change the order on this assignment so that it's the order that we mention it.
Well, we always say that.
But they have an order, you know, if you click it and put it in the order that they have it in, which is how we normally do it, that's why. So, yeah.
Okay, number 8. Look at what they're asking us to do. They want us to graph y equals the absolute value of x plus 2. And we know how the graphing tool works for absolute values. The first point you need to plot is that vertex. So, where does the vertex occur? The vertex will occur when the inside step is equal to 0. So this inside step, when is x plus 2 equal to 0? That's what you're asking yourself. You're thinking vertex, when is the inside step equal to 0? What are you going to get? -2. So here's my table. I'll have to use -2 for x, and that'll be my vertex. But we're going to have to plot another point as well to get the legs drawn. It's up to you what number you plug in for x. Give me something easy to plug in for x. What's my favorite number to plug in? 0, let's use 0. You could use 1. You could use +2. Just make sure it's a number that shows on the XY grid they give you. Plugging in -2, what are we going to get for y? Should be obvious. It better be 0, that's why we chose it. Now let's plug in 0. 0 plus 2 is, what's the absolute value of +2? Just 2. So we'll plot that vertex first.
And the instructions will say, plot the vertex. Okay? Okay, so we don't enter any numbers here. We just click here.
Click the absolute value tool.
And what was that vertex?
-2, 0.
Oh, good. This boxes aren't so small here. -1, 0, -1.5, 0,
There.
-2, 0. There.
And now notice this, we move that cursor around. The program is drawing every possible absolute value function with a vertex of negative 2, 0. That's making me dizzy. Stop.
Oh, okay.
And
Now
then
I'm gonna
the
plot
secondary
another
point that we got was 0, 2. If you had used 1, 3, we'd still, look,
Like, right, 1, 3.
I used 0, 2,
Right.
but there's 1, 3, and if we'd used the 0, 2 that I found, it's still the same line. I remember when they increased the size of those dots. The dots used to be real tiny. Do y'all see how huge they are now? They look sort of funny. But I think they were like, the programmers were like, I'll show those Precellas. They need big dots. So, oh goodness.
Yeah, so we got it right. Any questions?
Any
And this
questions?
is the tricky one because it's not just plot the first point, plot the second point.
The absolute value tool, you've got you've got to plot the vertex first. And when we study parabolas, keep going back to parabolas. When we're looking at quadratics in more detail in a few weeks, that fancy tool, it's no longer going to be the 3-point quadratic tool. There'll be a tool that it's like the absolute value. You plot the vertex first and then one additional point, and the symmetry takes care of getting the whole graph drawn. And so I'll remind y'all of that when we get to that.
They won't remember, so.
Oh, well.
And I don't mean that to sound bad. I wouldn't have remembered if I were a student. Oh, he told us this a few weeks ago.
Okay. So 1, 2, 3, 4, the absolute
One
value
more.
equation, and there's one more. Absolute values was number 4, Roman numeral 5. Square root.
Could you look and see if it's still multiple choice? It is.
I'm going to look through some other books and see if I can find. We don't have a square root tool for graphing square root expressions built into this course. I need to look and see if I can find it in another MyLab course. And so it's just multiple choice, so it's not nearly as fun. The things that don't have the move that over, Tony, and maybe. Oh, look at that. Yeah. There, okay. They're giving us 4 possibilities.
Just gives you a hint of what my math lab was like 15 or so years ago. Oh, heck, 20 years? Everything was multiple choice.
So this is back to number 4. Let's see, graph y equals the square root. Is that an x minus 3 or x plus 4? Minus 3. Okay. To graph a square root expression, what we're going to do is we're just going to plot points and then connect the points. We'll draw it on paper, and then whatever matches one of those 4 graphs, that'll be the answer. Here's the thing for square root equations. You're going to plug in numbers for x. You can plug in 50 million, but I wouldn't advise doing that. But what you have to do is avoid imaginary numbers. You can't get an imaginary y value. You say, oh, let's plug in something like 0. If you plugged in 0 for x, 0 minus 3, you have the square root of negative 3. That's imaginary. It's called imaginary because you can't label it on a number line. So what you need, the thing underneath that square root, whatever you're plugging in, you don't want that to be negative. You need a non-negative expression under the square root. Can we plug in 0? I love to plug in 0. Can we use 0? No. To get the starting point on the graph, do the same thing you did over here for absolute values to find the vertex. To find the vertex of an absolute value, you ask, when's the inside stuff equal to 0? Ask yourself the same thing here. When is that inside stuff equal to 0? That'll get you a starting point. When is x minus 3 equal to 0? Well, that gives us when x is equal to 3, okay. So here I have my table of values I'm drawing out. I'm going to want to plug in 3, and that'll be our starting point. Now I'm making a note. I'm not going to call it a vertex. I'm just going to call it the starting point. One side of 3 is going to generate imaginary y values. That part of the graph is going to be empty. The other side will give you numbers that are actual real numbers. So let's use a number smaller than 3 and one bigger than 3. Well, if we plugged in 3 for x, what are we going to get for y? That's easy. If we plug in 3 for x, what are we about to get for y? 0. 3 minus 3 is 0. The square root of 0 is still 0. So, what if you plugged in 2 for x? What would happen? Can you use 2? One side is okay, one side isn't. Suppose you plug in 2. You get y equals the square root of 2 minus 3. 2 minus 3 is negative 1. What's the square root of negative 1?
It starts with an I. You're thinking absolute value, not square root.
It's going to be imaginary.
So you can't plug in anything smaller than 3.
If you plug in something smaller than 3, like a 2, you're going to get the square root of a negative. Remember, you need the square root of positive numbers, so you can't do this. That is imaginary. There's no graph there. I guess it's just something in your imagination, okay? But you're not going to have anything drawn to the left of 3. Plug in 4. So as you plug in 4 for x, let's plug in 4. What are we going to get? Y is equal to the square root of 4 minus 3. Well, 4 minus 3 is 1. What's the square root of 1? 1. Notice these to the right of 3, we're getting real numbers, numbers we can label on the y-axis. We could plug in something like suppose we plugged in a 5. Plug in 5 for x. What are you going to get? 5 minus 3 is 2. Is 2 a perfect square? No. I just know from, I know that 14 times 14 is 196. So 1.4 times 1.4 would be 1.96. That's approximately 2. So we can put that's approximately a 1.4. Why don't you tell me an x value that we can plug in that'll give me a perfect square? I don't want to mess with decimal numbers. If I plug in a 6, am I going to get a perfect square? 6 minus 3? No, that's a 3. What if a 7? Plug in a 7. Plug in a 7 for x. What are you going to get? 7 minus 3 is 4. What's the square root of 4? There. I think we have enough points right here. I'm going to plot them using this point. I'm using the integer coordinates.
Oh, no. You're not doing 4, 1?
Oh, yeah, 4, 1 is the one I want to do. I'm not going to plot that 5, comma, 1.4. I'm going to do 3, 0, 4, 1, and 7, 2.
And then
And
one
I'm
of the
drawing
multiple
this by
choice.
hand. Because it's multiple choice, I'm going to draw it by hand, and then we'll look at the 4 options and choose the one that looks like our picture.
Now, most people probably won't draw it by hand when they're doing it for themselves, for the homework. They'll just get a few points and look at the options. Did you do 7 marks? 1, 2, 3, 4, 5.
Oh, shoot. 6, 7. There, I gotta keep going. Okay, so 3, 0. That's my starting point. 1, 2, 3. Right 3 up 0. And then 4, 1. Right 4 up 1.
Looks like a line.
Yeah, for a moment. What about 7, 2? 4, 5, 6. Here's 7. We're only going up 2. Well, 5, 1.4 would be right out there, but I don't think we need to plot that. It looks like it starts here at 3, 0. It's going up. It continues to go up, but this is a very gradual increase. Suppose we plugged in 103. 103 minus 3 is what?
100.
What's the square root of 100? 10. So if you went out 103 units out here, or be over there by that folding wall, you're only up 10 units. So it's going, the graph is increasing, but it's very gradual. The bigger the X values get, the slower the rate of increase. But that's all stuff you don't need to know. You need to look and find what graph starts at 3, 0.
Definitely not.
Can we clearly say definitely not A? What about B? Oh, if you move it over like this.
Yeah, you're right. I should have done. I've already done that.
Yeah, but when you left and you came back. What do y'all think? Is it B? No, clearly not. What about D? Is it D? I think they're plot. I'm not sure what they did to get D. The only thing that starts on the X-axis, and if you look.
Oh, I was going to say do that.
Oh, do this one, make it pop out. There's, I guess they're incrementing in units of 2. 2, 4, 6, 8, 10. So 3 is right between 2 and 4. I think option C is the only thing that comes close.
Any questions on why I chose C? You just plot enough points
to see what it looks like and choose the picture that's closest to the one that you got.
The absolute values are V-shaped. These square roots have a definite starting point, and then it just goes up slowly. Okay.
Any questions there? Okay, and now we have a few formulas. The distance and midpoint
Who was
formulas.
it in here before class was asking, when are we going to have more formulas? We haven't had any formulas in a while.
Yeah, we're going
So
to have them now.
some formulas now.
The distance.
And no one asked that.
I was wondering, wow, someone's really on the ball. Oh, distance and midpoint formulas. Okay, let's suppose we have two arbitrary ordered pairs. Here's an XY grid.
You're going to define what you mean by distance, though, aren't you?
Yes.
I think most people know what you mean by distance, but okay.
There. Let's suppose we have two arbitrary ordered pairs, and I'll label them X1, Y1, and X2, Y2.
Just meaning first X, first Y.
First X, X subscript 1, comma, Y subscript 1. That's saying the X coordinate of the first order pair and the Y coordinate of the first order pair. And we have a second point.
How do you think we're going to label it?
Oh, out of laziness, instead of saying X subscript 1 and Y subscript 1, I could say X sub 1, Y sub 1, or my real lazy way is to say X1, Y1. How do you think I'm going to denote this second point?
In a real lazy way.
How will I denote the X coordinate of the second point?
X.
X2, comma, y2. Okay. Technically, that's x subscript 2, y subscript 2. If we drew the line segment connecting these two arbitrary points, and then, let me see. Let's see.
Should have brought you a ruler. Student gave me this mouse pad back in
2002.
Oh, okay. When this James Bond movie was new, and I can't ever throw it away because a student gave it to me. So I still have it. First time it's been used in a long time.
Okay.
What do y'all think the distance is going to do? The distance formula.
The distance tells you the length of the segment connecting those 2 points. When I talk about the distance, I mean the shortest distance. You take the measuring tape, you put it here, you stretch it over here to, I guess no one uses measuring tapes anymore.
And I think also everyone knows what you mean by distance.
Oh, so that length of the line segment, I'm going to write that as, I'll say the length of the line segment is what I call the distance. And we'll have a formula for that.
Could y'all sort of look and figure out where's the point that's right in the middle? Where do y'all think the point is right between these 2 points?
The point that divides that line segment in half by length. Let's see.
That's called a midpoint.
Let's see, is it right out here? What do y'all think? This point, right there in the middle of that line segment, is called the midpoint.
Now, that's not a word you use every day, but most people use the word distance.
Oh, I think that if I ask, oh, what's the midpoint between here and Houston?
Yeah.
I mean, yeah. I normally think Victoria,
But
although
not
it
really.
really isn't, but for some reason I think of it as being. So the midpoint is the point that divides that segment in half by length. From the midpoint to that point there is the same distance as the midpoint to that second point.
Do y'all want him to keep talking, or do y'all want him to state these formulas? Is it time for him to write the formulas? Yes? Okay.
Okay.
State the formulas.
No, I'm going to let Tony do that. I did all the fun stuff, the graphic stuff.
Okay.
So, there.
Okay, so to calculate the midpoint. Don't panic too much when you see it. I'm going to say D for distance equals, and it's going to be a big square root. And of some parentheses squared plus parentheses squared minus here and here. And inside these parentheses, you're going to subtract the x values. Second x minus first x squared plus, again, today I'm all about patterns. I'm wondering if y'all could figure out, we went second x minus first x in this first set of parentheses. Do y'all want to guess what's going to go in the second set? Look at the pattern. Perfect. Y2 minus Y1. So that's that formula, and I'm going to do some examples with it in a moment. We'll calculate that distance. Okay? Now I'm going to go ahead and state the midpoint formula. Also, when we talk about a midpoint, it's an ordered pair. The midpoint is an ordered pair. That means you have an x value and a y value. If you had two numbers and you had to average them, could y'all tell me in great detail, how would you average two numbers? What would you do first? Add them together and then do what? Divide. Here's what you're going to do. Here's the midpoint formula, loosely stated, you're going to average the two x's, which, what did y'all say that means? Add them and divide. And then, following the pattern, I'm all about patterns today. What do y'all think I'm going to write right here to get the y coordinate of the midpoint? Average the two y's. That's right. Well, wait a minute. That's not a formula. Formula's got to be written out. So y'all said to average, you add them up. To average two numbers, you add it up, divide by 2. So add the two x's, divide by 2. Add the two y's. Addition is commutative, so it doesn't matter which ones you add first. Just add the two x's, whether it's x1 plus x2 or x2 plus x1, it'll be the same thing. Divide by 2, and the same thing for the y's. When you're typing in the answer, the midpoint, that gets tricky because it's got to be an ordered pair, which means you've got to have what around the numbers? Parentheses. If you don't put the parentheses, guess what it's going to do? Is it going to count it right? No, it's going to count it wrong. And you got to put the comma also. Mm-hmm. But let's see. Let's do number 9. 9 and 10 are the two. Starting at 11, it's old material, review material. There's only 10 problems of new material in this assignment. It says, for the point P and Q, find the distance dPQ. And that means the distance from P to Q. This notation here is their lazy way of saying the distance from P to Q and the coordinates of the midpoint. So I think there's a lot more words there than we need. Yeah. Let's see. I'm going to do this so y'all can sort of see. I'm just writing down those points. -16, comma, -13, and -11, -10. So if y'all can picture those two ordered pairs, we're trying to find the distance right between them. I'd identify which the first ordered pair I write down. I'll label that x1, y1. The second order pair I'll label as x2, y2. Now I encourage you to write the formula, assuming we're using distance first. Write that formula out. Distance formula. It's got those parentheses. That's the one with the distance formula is the one with the minus in it. Okay? Well, in the parentheses. Okay? There's still a plus there. So it's x2 minus x1 plus y2 minus y1. So you're subtracting the two x's and then square them. Subtract the two y's and square them. Add them together and take the square root. Okay. You plug in the numbers. What number's going to go right here where I'm pointing? Y'all will be so excited to know that -11, I agree. What Pearson is doing now is when there's formulas, they're starting to, like in my business math class, Math 1324, I was shocked to learn. They're now making the students, they give them the formula, and it's messy formulas. And they've got to type in these little boxes, each number that goes in there. I'm like, oh my gosh, I didn't know they'd started doing that. It was online. So I had to sort of find some old problems to replace those with. I don't want the students, spending all day typing in these little boxes. But what am I going to put right here? -11. Then we have the minus from the formula, and we're about to get a negative 16. What's going to happen? This minus a negative? Yeah, that's going to be a positive. I'll put a plus right there. Now here, what am I going to write?
I think it's a positive 10. Or did I miscopy, or did he miscopy the problem? Hold on. It is a negative 10.
Oh, wow.
Thank you.
Thanks.
Thanks.
Oh.
That's negative 11 comma negative 10.
Did I miscopy anything else? No.
No.
Okay.
Thanks.
Okay.
So we have a negative 10.
Negative 10.
What's going to go here?
Minus. Okay, it's going to be a plus because you're going minus a negative 13. So I'll just make it plus like that. So it all looks black, but it's supposed to be a black minus, and then I'll put a vertical minus 13.
So let's simplify inside the parentheses.
Negative 11 plus 16. Is that going to be a positive 5? So we have a 5 squared plus, what about over here? Negative 10 plus 13 is 3 squared. So let's see. Underneath that square root, 5 times 5 is 25. 3 times, did I say 5 plus 5? I meant 5 times 5.
I think you said 5 times 5.
Oh, okay. And 3 times 3 is 9. So what number are we getting under this square root? 25 plus 9, 34.
Is 34 a perfect square?
No.
Is there a perfect square that divides evenly into 34 so we can reduce that square to 34?
What are the only two numbers that divide into 34 other than 1 and 34?
I think only 2 and 17.
2 and 17.
Both of them are prime.
And so, can we simplify square root of 34? No. Just square root of 34 stays square root of 34.
So the distance, click, remember, the square root key is in the toolbar, type 34, and now you're ready for the midpoint.
So midpoint. To do the midpoint, you're adding up the two x's and dividing them by 2. So add the two x's, divide by 2. Add the two y's, divide by 2.
So what's going to go here where my point cursor is? What am I going to put there? Negative 16 plus here, negative 11, I agree. Now for the y coordinates here, negative 13 plus negative 10. Good.
What number do we have on top of the first fraction? Negative 16 plus a negative 11 is negative 27. And what about on top of the second fraction? What number are we going to have here? Negative 13 plus a negative 10 is a negative 23. So in terms of decimals, which we're not going to type in as our answer, we'll type in fractions. Pearson doesn't usually like decimals unless it's dealing with money. Okay, my business math class, they use a lot of decimals because it's dollars and cents. Let's see, negative 13.5 and negative 11.5. That's probably how you would think of it if you were going to graph it, but we're not going to plot it or anything. We're just going to type it in. So can you type that in, Tim?
I sure can.
Oh, by the way, do you agree 2 doesn't divide into either of those numbers? There's nothing we can do to reduce it.
Left parentheses, negative 27 over 2. Get out of the denominator before you type your comma. Negative 23 over 2. Get out of the parentheses before you
out of the
denominator before you close your parentheses.
And let's do number 10 real fast.
Now I can't see the.
It's the same type of problem.
Same type
just 2
of problem.
different points. Oh, good. I'm glad that 9 had a lot of. Sometimes when we're doing these, they'll both have a lot of negatives, which is good. Other times there'll be no negatives in them. They'll both be like this number 10. I like to do some with the negatives, but number 9 had negatives, so good. You can see if you're lucky. If when you do these, if you have no negatives in either of those, go buy a lottery ticket. You're lucky today.
You're lucky day.
So 619 and
1124.
Go ahead and label X1, Y1. Make sure you're labeling X1, Y1. The common mistake, people will go X1, X2. No. An ordered pair is X,
of the first
Y.
ordered pair, the Y coordinate of the first ordered pair. The X coordinate of the second ordered pair, the Y coordinate of the second ordered pair.
And X minus. Okay, so talk me through which ones are we gonna, what am I gonna write here? X2 is 11, so we have 11 minus 6. And over here, what am I going to put? 4 minus 19. 11 minus 6, that's a 5. So we have 5 squared plus, what about 24 minus 19? Is that another 5? So 5 squared is 25, so 25 plus 25 is 50. Am I going to type in square root of 50 as an answer? No. Why? Yeah, what perfect square divides evenly into 25?
Into 50.
Into 50, okay. Messed up. 20, yeah, you're right. So I'm going to think of 50 as square root of 25 times the square root of 2. I'll write a black 5. And then just leave the red square root of 2 as a square root of 2. So 5 square root of 2 is our answer on that for the distance. Any questions?
Not through. Gotta find the midpoint.
I know that. I just meant any questions. Most people consider the distance formula a little more
messier than the midpoint.
So for the midpoint,
Tony, here's the midpoint formula right here. So I don't even think you have to rewrite it, so it'll all fit on that same page.
Okay, you're right. So it's add the two x's, divide by 2, add the two y's and divide by 2. So
what's going to go here where I'm pointing?
First x is it 6?
Here where I'm pointing. 11, okay. We're still using
no idea how many
ordered
people will
pairs.
do 6 and 19. No. Make sure you're going x1, first x, second x. Over here, first y, second y. And let's see what we're going to get here. 6 plus 11, 17. So we have 17 over 2. And what about 19 plus 23?
24.
24. Is that going to be a 43?
Mm-hmm.
To either of these, can we reduce either of them? Does 2 divide into 17 or 43? Am I finished? Yeah. So the point right in between there would be 8.5 or 8.5 and 21.5.
So if you plotted these 2 points, what we found is that 8.5 is midway between 6 and 11, and 22.5 is midway between, it's 21.5, is midway between 19 and 24. I better type this in. And what was it?
17 over 2.
And
43 over 2. Are eager to get out of here. So, starting with number 11, it's all old stuff. Okay? I think number 11 is what? Stuff, the first stuff from solving. Remember these? What numbers can't possibly be solutions?
When are fractions undefined? What could x not equal here? Positive 2. When the denominator's 0. What about this one? Negative 4. Okay,
yeah.
I'll remember.
Okay, so work on that. You also have review for quiz 1 you've got to be working on. If you're thinking, oh my gosh, there's so much work, it seems like it's work for 2 classes. This is two classes. Okay.
And if you haven't felt like it's been lately, you're going to feel it now as you're trying to do the assignments, got reviewing for the quiz. You also have to review for the test. So, and we're going on to lines on Monday. Every review here
has the video of us working it out.
But the review is for
on your own.
That's your own thing, okay? You
There's
do
no
that
way
review.
we've tried it, and there's just no way if we're going to spend the class period working out the review, then we're going to wind up being really rushed on some of the other stuff.
On the review, you're also, for that one, you also can't have anyone in the room.
Oh, wait.
Oh, no, the review's just like a homework.
Oh, okay.
I better stop.